Okay, so let's see the second question. So basically today the second question and fourth question are the same except the constraints. So this was the third question. We have given an integer array nums a and b. Okay, x is the in subarray, right? For a subarray, x is count of even, y is count of odd, and the ratio is defined as x by y. Okay, and a subarray is valid if x by y, that is for even, right? Even upon odd less than a by b, right? This is the condition then we, okay. So see, for the brute force approach, right? See, n equals to 1000 simple. Okay, and in the second question, the same question. Okay, same question. The only constraint is n less than equals to 105. Now, what the question asks, right? We have to choose a subarray from this index L to R, right? Some L1 till right R, and we have to tell, right? Let's say odd count, right? Odd count equals to x, sorry, odd count is y, even count is x, then we need to tell this condition, right? So how many arrays, right? How many subarrays, right? Satisfy what condition they satisfy, right? They satisfy y into, sorry, y divided by even, right? Less than equals to a by b. Okay. So first is the brute force approach. Simple, right? You loop, right? For what? Let's say I equals to 0 to n, for j equals to 0 to n. See, the question only says, right, the constraints are n. If we have to run this constraint in O of, right, right, 1 billion operations we can do per second, right, basically. So this will simply run in O of n because O of n square, right? N square is 10 raised to power 6 only, right? So you just do loop, you keep count of odd count, even count, check ratio, right? That's it. So whatever, right, you do, you check condition, right? You do odd count, you have even count, then check condition, right? Check condition. If valid, increment our answer. Okay, that's it basically. This condition you can write basically x into b minus y into a less than equals to 0. Okay, so this is the answer for the third question, simple answer. Now I'll see the optimized version for this one. Before solving, let's observe this equation, right? The equation says us, right, even count upon odd count, right, less than equals to a by b. See, this is my biggest advice to you. All questions that involves this mathematical equations or something, right? First try to like transform them into some simple equations. So once you get, then the approach is basically pretty much a straightforward. See, like you see in this question, see, this is what we have given, right? Can I write this as I'm going to write this as E. I'm going to write this as O. So can I write some E into B minus 1? A into O less than equals to 0. Can I write this one? See, multiply this one, and just reverse. Okay. So the next is see, for any index j, for any index j, it is aj minus b into oj into a less than equals to 0. For I, it's ai b minus oi a less than equals to 0. Same. For index pair I comma j, right? What can I write? See, if j comes after, so it will be like this, right? Aj minus ai b minus oj minus oi into a less than equals to 0. See, this is even count, right? This is odd count. E where, right? Ej denotes, right? total even till index j. So you understand, right? Okay. So now what, see the above equation, how can I write it again? See, I write it easy into b minus og into a. Is this correct? Minus, see, ei into b, sorry, ei into ei. See, this is j. Ei into b minus oi into a less than equals to 0. You see, this term, right, is the same as the above equation. So let's write this. And for any index j, it is fixed, right? It is fixed for any index j. So can I write this as pj minus pi less than equals to 0, where pi equals to, right, some ei into b minus oi into a. Is this equation correct? So now for pair, right, for index pair, right, I comma j, for subarray, say this is subarray, right, I to j. For this subarray, what we have to tell, right, pj less than equals to pi, such that j greater than I. What is this? Count of inverse pairs. Simple, right? Count of inverse pairs, standard question. So I think if you go on YouTube, there are like flood of these count of inverse pair videos. So there are various approaches that you can use. So there's one is binary index tree, or is, we say it right, Fenwick tree. We can use ordered set. I generally use ordered set for this question. I generally code in Java, but whenever there is a question that involves this complex, right, this complex data structure, I just have to C++. Back to basics. So in the ordered set, it's simple, right? In the ordered set, what we do, there is a method known as order of key. Okay, order of key of x. What it gives, number of elements strictly less than x, right? See, for any index j, what we need? We need the count which are greater than I, basically, right? So for any index, right, we need, right, number of pairs which are greater than or equal to current pi. So how we are going to do this, right? Our ordered set, right? So this ordered set generally, uh, it is for distinct characters. So if you want equal, you generally use less of equal, but that's not a good approach, right? So alternative is to use a pair, pair of word, your key and some unique ID. So you can simply use it, right? Pair of your value and index. So if you use pair of value index, all are unique, right? All values unique. So what you are going to do, so you initialize ordered set, let's say OS. Then what you're going to do, for I equals to 0 till n, you have some odd count, some even count O. Okay, then what you are going to find p equals to what? So what was our value of p? See, p is ei into b. See, p is a into b minus our odd count, right? Odd count into a, right? Then you, what you found, right? So count equals to what? You do order of key So what is our key now? Is p comma minus 2. So why this? Because we need strictly smaller. Okay. Then what are valid pairs, right? Answer plus equals to what? Whatever is the size of our ordered set minus what is the count of strictly smaller, right? Which gives the correct values. Okay. So then just answer. So you can also solve it using this binary index tree. Binary index tree is basically used to do the range max queries or something. Range minimum queries, range maximum queries, right? And when this is used, when one of the end is fixed. When one of the end is fixed. So in this case, right, this 0 always fixed because we have to always find is this range, right? Always find in range. What do you say? 0 to some high. That's why we can use the binary index tree, say Fenwick tree, and other approaches. Okay, that's it. Simple question. So if you want to see the code is also simple. The same code, right? What I've told you now. We declared an ordered set. Ordered set is of a right pair of what do we say? Key, comma, index. Basically, right? So we have our ordered set. This is our equation, right? Pi equals to what? Ei into b minus oi into a. Then see we find that strictly less than equals to pi. Count is what? Total minus pi. Sorry, total minus count. Simple question, huh? That's it. Thank you.